We are now up to section 9.5 entitled Lines and Circles. Let's do a quick recap. We've already covered central angles and inscribed angles. Central angles are probably my favorite. Here's this pink angle B, which is a great example of that. So that central angle, angle B, will be equal to the measure of its intercepted arc. And you know what, I'm also going to mention the vertex of a central angle is in the center of the circle. Now, an inscribed angle, like this green angle A here, has its vertex on the circle, and angle A will be equal to half the intercepted arc. So that would be half this arc right here, which also means that A would be half the measure of angle B. All right, so that's just a recap. We've already talked about those things. But today, we are going to add two new types of angles to our list. All right, first type I would like to look at. It is an interior angle, so it's still going to be inside the circle, but the vertex is not going to be at the center, like a central angle, and the vertex is not going to be on the circle either, like an inscribed angle. All right, I took this out of your book for you, so you can either turn to page 395 and look up theorem 9.18, or you can look right here on the screen and copy down that theorem and the figure into your notes. All right, the measure of an angle formed by two secants that intersect in the interior of a circle is 1/2 the sum of the measures of the intercepted arcs. Okay, jot that down. Jot down the picture. We're looking at angle 1. So angle 1 in this figure is a great example of an interior angle. It's inside the circle, in which the vertex is not at the center and the vertex is not on the circle. So looking at angle 1, here's its vertex, vertex E. Notice it's not on the center, that would be at Q, and obviously it's also not on the circle over here somewhere. Now this angle, the measure of this angle, angle 1, is going to be equal to the sum, 1/2 the sum of the measures of the intercepted arcs. So we are going to add arc AB and add arc DC. Once we get that sum, after adding those two arcs, we are going to divide that by 2 or multiply it by 1/2. Either way you could think of it. And that will give us the measure of this angle 1. Let's take a closer look at this. All right. I like to call this the X rule because it just looks like a big X inside your circle. So it's a really good way to identify it. So I'm going to refer to this as the X rule as we continue. But here's the rule kind of written out for you nice and clearly. So this arc X and arc Y are the two intercepted arcs. You add those and then multiply by 1/2. Or you add those and then divide by 2 to get the measure of that angle here. And again, this shows you why I'm calling it the X rule. You can see how it makes that X in the circle. Now, how would I find angle Y? So it looks to me like angle Y is an interior angle or an internal angle. It follows the X rule. So we're going to add 111 plus 65, get that answer, and divide by 2. And that will give us the measure of angle Y, 88 degrees. Now, I want to show you how both Y, and I marked this in blue on this picture over here so you can see this, Y is not the only angle that's 88 degrees. Its vertical angle right up here, this other blue angle, is also 88 degrees. Now, I feel like we know enough in geometry to be able to figure out the measure of angle X as well. So let's take a look at this. It looks to me like X and Y are a linear pair, which means if I just subtract 88 from 180 degrees, I should get the measure of angle X as well. So let's go ahead and do that. And angle X is 92 degrees. All right. I guess that tells me if this diagram had started off and there was no Y in the very beginning and it just said find the measure of X, I would have actually had to still find the measure of this angle first, angle Y, and then subtract 180 to get X. So sometimes you do have to do that extra step in your problem. All right, your turn. I would like you to find both Y and X in the circle below. Now again, you can't really find X until you find Y. So go ahead and find Y first. You pause the video, take a second to do that. All right, I'm hoping you added 106 and 60. Got that answer, divided by 2, which would have given you Y. Once you had that answer, 180 minus that will give you X. you should have gotten 83 degrees for X and, I'm sorry, 83 degrees for Y and 97 degrees for X. Awesome job. Time for your secret mission. When you think of the Lord, write down a word that starts with B that comes to mind. Please include that in your notes today. All right, time for the second new type of angle to add to our list. This time, we are going to look at an exterior angle. So this angle is going to happen outside of our circle that is formed by a combination of tangents and or secants. All right, this time I'd like you to copy down from page 394, theorem 9.17a. Go ahead and copy down both the theorem and figure 9.23 in your notes. Again, I added it to the screen for your convenience. Let's take a look at it. The measure of an angle formed by two secants that intersect in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. Very interesting. So our last rule, we had to add 2 arcs and divide by 2. In this rule, we subtract 2 arcs and divide by 2. Angle 1 here, that's our example. It's actually a great example of an exterior angle that is formed by a combination of tangents and or secants. So I'm taking a look at this angle 1 right here. I'm noticing that it actually intercepts 2 arcs. Look, it intercepts this big arc over here, arc CE. I'm calling it a big arc. It is still a minor arc. It's just big compared to the other one I was looking at, because the other arc I was looking at was arc BD. So this angle 1, see how when it opens up, it cuts off both of those arcs. It's cutting off arc CE, and it's cutting off arc BD. So you would take those 2 arcs, subtract them, and then divide by 2. All right, let's take a closer look at this rule. All right, I call this rule the ice cream rule. I don't know if you see it, but I kind of see this as a large ice cream cone. I even drew ice cream and a cherry on top. It's kind of laying over to the side, which is a little unusual for ice cream. But this is why I call it the ice cream cone or the ice cream rule, because I see this ice cream cone here. And then you can see clearly how this green one is the large arc that's intercepted, and the yellow one is the smaller arc that is intercepted. I really like this picture over here as well because you can see it with the colors. So you take arc X, subtract it from XY, and then divide by 2 or multiply by 1/2. Same thing. And it gives you this exterior angle measure out here. All right, so let's take a look at how we're going to use this ice cream rule in this example below. So I'm trying to find angle X. Now I know angle X is written all the way over here. These are vertical angles. They're also referring to this angle right here. So angle X is here and angle X is here. All right, that being said, let's use the rule. I'm going to take the larger arc that's intercepted, 41, subtract it from 23, and divide by 2, and I'm going to get that X equals 9 degrees. All right, your turn. Find X in the circle below. Again, your X is here. Your X is also here. Go ahead and pause the video, get an answer for X. Did you get X equals 21 degrees? I hope so, because 60 minus 18, divide that by 2, and there you get your 21 degrees. All right, I want to try another ice cream one together. It's a little bit trickier because I just said the rule was take the big arc, subtract the little arc, and divide by 2 to get this angle here or this angle here. But looks like I'm going to have to set up an equation to work this one out. So let me move my 29 right here. So 29 is also right here. Looks to me like X minus 64 all divided by 2 will equal 29. So go ahead and write out that formula. X minus 64 all divided by 2 will equal 29. All right, no problem. Now I just need to solve that for X. I could multiply both sides by 2 and then add 64. Let's take a look and see what that looks like. So I multiplied both sides by 2. Then I got X minus 64 equals 58. Add 64 to both sides. I've isolated X. X is 122 degrees. If you're feeling not confident in this, you could check your answer. So I got 122. So let's just make sure. Is 122 minus 64 gives me 58. If I take 58 and divide it by 2, I do get 29, which is that exterior angle that I was looking for. Let's take another look at another example that can be a little complicated with this ice cream rule. All right, you're seeing there's the ice cream cone again, opening up. Uh-oh. Looks like I'm almost missing information here. So, let's see. This is 78 degrees. This arc is X. Pause this for a second. Okay, so I'm hoping this highlight will help. Let's take a look. The 78 is this angle right here. Now, I made the large intercepted arc red for you and the small intercepted arc green. Now, we know the small intercepted arc is X, but how big is this red intercepted arc? Well, if the whole circle is 360, this arc must be 360 minus X. So I'm going to think of this red arc as 360 minus X. I'm going to think of this green arc as X. And then I could do the red arc minus the green arc, all divided by 2, should equal 78. So let's set up our equation. The red arc, 360 minus X, minus the green arc, just X, all divided by 2 should equal 78. Now we'd have to solve that out algebraically, and I will show the work here. You can pause it if you want to try it on your own first. And then it looks like to get rid of my 2 in the denominator, I multiply both sides by 2. Then I'm left with 360 minus 2x if I combine like terms here equals 156. Subtract 360 from both sides. Then when I'm left with negative 2x equals negative 204, divide by negative 2 on both sides. And my final answer is x equals 102 degrees. Now, does that make sense? If x is 102 degrees, the green arc is 102. That would mean 360 minus 102, 258. The red arc would be 258. If I take 258 and I subtract 102, and then I divide it by 2, will I get 78? Yes, that is a good way to check your work, especially on a tricky one like this. All right, mission accomplished in terms of all 4 of our angles. You now know the central angle, the inscribed angle, the internal angle, which I really like to call the X rule, and the external angle, which I usually call the ice cream rule. Let's look at them one more way. All right, I prefer this picture, to be honest with you. The central angle, again, where it just equals the arc. The inscribed angle, where the angle equals half the arc. The X rule, where you add the 2 arcs and divide by 2. And the ice cream rule, where you subtract the 2 arcs and divide by 2. To kind of do a nice little summary there. Let's take another look at this ice cream rule up close. Now remember I said that it can be formed by a combination of tangents and secants. You might have 2 tangents, 2 secants, or 1 of each. So it could look like any of these, but they still kind of have that ice cream cone look. Here with a tangent and a secant, again, you can just see the red minus the blue, divide by 2. Here you can see it with the 2 tangents. Again, the red minus the blue, divide by 2. And here you see it with the 2 secants. Again, the red minus the blue, divide by 2. I also wanted you to take a quick look at a problem like this, because I don't want you to confuse it with any of the types. A classic example of an inscribed angle. This is 40 degrees, this is 80 degrees. So the angle is half the arc, or the arc is double the angle. You could think of it either way. But how do you treat this one, example B? It's interesting how it follows the same rules as an inscribed angle. The reason for this is the vertex is on the circle. That's the key to this one. The vertex is on the circle, so it follows the inscribed angle rule, and it means that this angle, angle JKL, is 1/2 the intercepted arc, which is arc JK. So 50 is 1/2 of 100. All right, that being said, take a quick look at this one. What about this picture? Is that a central angle? Is it an inscribed angle? Is it following the X rule, the ice cream rule? This could be a little tricky. I know you might see an X here. When I call it the X rule, I'm seeing an X inside the circle. This is definitely not an X rule. I don't see an angle that is completely outside the circle. All I see is this vertex on the circle. So it's not an ice cream rule. It's obviously not a central angle because it's not on the center either. But angle 1 is actually going to follow that inscribed angle rule, just like the previous slide, because the vertex is on the circle. Now, I don't want you to be confused because it is formed by a tangent and a secant. I know we're talking about ice cream rule typically when we talk about those tangents and secants coming in. I want you to really focus on where the vertex is. The vertex is on the circle, so it follows the inscribed angle rule. All right, great job today. You are officially ready to complete your comprehension check assignments. Please make sure you do submit a picture of these notes, and then you can go ahead and move on to your comprehension check assignments listed on Google Classroom.